Okay, so the sum of a geometric series, remember the formula for the sum of a geometric is a over 1 minus r. So your a in this case is 2, it's always the first term. Your r in this case, notice you're multiplying by negative 1/2 every time. So it's 1 minus r, and then if you clean this up, this is 2 over 3/2. Flip the second fraction, this is going to give you 4/3. Okay, which of the following series converges? So let's go, this is a p series, p is 1/2 here, so it diverges. This is a p series, I also know it diverges. Okay, this one is not a p series, but remember, anytime you have polynomials on the top, on the bottom, we could compare it to a p series. So this is a p series that converges, and remember, using LCT, I know that whatever you compare it to, the entire series will do the same thing. So I can say the entire series, 2 over n squared minus 5, will also converge because what I compared it to also converges. So the only ones that converge is going to be C, 3 only. Okay, so I need to figure out which one of the series matches up with this sigma. Notice all of your answer choices, except the last one, is a series that we should know. Remember, we know sine of x, cosine of x, e to the x, etc. What I would do is write out the first couple terms and see if I can recognize it. Notice this starts at n equals 0, so if I plug in 0, everything becomes 1. That's my first term. Then I'm going to plug in 1 for n, so I have a negative x to the first over 1 factorial, which is just 1. If I plug in 2, you get a positive x squared, and then 2 factorial on the bottom, etc. So we have to figure out which one of these it is. Okay, so I know it can't be a, b, and c because I have these memorized, hopefully. So I know sine of x is x minus x cubed over 3 factorial, etc. So it's not that one. Cosine of x is 1 minus x squared over 2 factorial dot dot dot. It's not that one. E to the x is, remember, 1 plus x squared over 2 factorial, etc. So it's not that one. But notice this looks very similar to this one. The only difference is, notice that here I have a minus, here it has a plus. So e to the negative x would be replacing the x with the negative. So this becomes minus. This is negative x squared, which still gives you the positive. So this is this series. So it's recognizing which series is, but you have to have e to the x, cosine of x, and sine of x memorized. Okay, the next one is very similar. So notice you're working off of sine of x, and notice all my answer choices are Maclaurin, so you're centered at 0. So if you remember, sine of x is x minus x cubed over 3 factorial plus x to the 5th, dot, dot, dot. So dividing by x just means you divide every term through by x. So this divided by x gives me 1 x squared, right? We are just dividing every term through by x. And which one of these does this match up to? And this one is just only A. Okay. Conditionally convergent. So remember, there are 3 categories you can put a series in. It's either absolutely convergent, conditionally convergent, or divergent. So I always check the absolute first because that's the easiest one to check. And absolute conversion just means if you look at just the absolute value of the series, what happens? So let's look at the absolute value of all of these. So the absolute value of the first one would be this. Absolute value of the second one is this. Absolute value of the last one would be this. So basically it's all the series without the negative 1. So these I can tell pretty easily. This one is a p series that diverges. This one is a geometric. R is 1/3, so I know it converges. This one, I can use LCT. You can compare it to a p series that diverges, so I know this also diverges. Okay, if the absolute value converges, like this one, we can say this one is absolutely convergent. So we're looking for conditionally convergent. So this one is called absolutely, so it can't be 2. So obviously that rules out this one, and this one, and this one. So notice if you look at your answer choices, it's really just going to be 1 or just 1 and 3. So really, you can just check this one here, okay? So now I want to look at the entire series with the -1. Anytime we have that -1, we can always use alternating series test. And remember, we talked about if all you have is an alternating series and all you have is n's on the bottom and just numbers, we can say for sure it's going to converge. So because the absolute value diverged, the entire series with the -1 converge. So you have one of each. This is called conditionally convergent. Okay? For number 1, you could do the same thing. Oh, I guess we have to check 1 also. Same thing. If I look at this, I'm going to use alternating series test. Again, all I have is numbers and n's on the bottom, so I know that this converges. So the absolute value diverges. The series with the -1 converges, so this one is also called conditionally convergent. So it would be D. Okay, this one here, we are looking at natural log of x plus 1. This is not one of the series that we have memorized, sine of x, cosine of x, or e to the x. So the only way to do this one is to go ahead and take your derivatives. So, okay, I'm gonna change this just to f. Okay, and I need the first 3 terms, it looks like, so let's come up with the first couple derivatives. This is 1 over x plus 1. I'm going to just start with these and see if it helps me to come up with my answer right away. And we are going to plug in 0 in for x. So if I plug in 0 in for x here, I get natural log of 1, which is 0. So that means your first term is 0. That means you do not have a term with just a number. So it can't be b, it can't be d. This one here, when I plug in 0 for x, notice you get 1. Right? So remember the way we write our polynomial. We start with f of 0, which is 0. Obviously, I don't have to write that. Your first derivative is 1 times x to the first. So I know my first term has to have x. So it can't be a. So I need my second derivative here to get. So my second derivative, so remember this is x plus 1 to the -1. So I'm going to bring down the -1, reduce the power by 1. So this is really -1 over x plus 1 squared. And if I plug in 0 here, I get a -1. So the next term would be second derivative x to the squared over 2 factorial. And that gets me down to choice C. Okay. The next one is asking about radius of convergence. Remember when they ask about radius or interval of convergence, you either have to use the ratio test or it could be a geometric series, then you could just look at the R value. This is not a geometric because of this k plus 1 on the bottom. So I'm going to use the ratio test. So remember, ratio test says you take the n plus first term. So I'm going to replace k with k plus 1. So that means this really becomes k plus 3. And then I have x to the k plus 1. And the bottom becomes really k plus 2. And you're going to divide by the original. So I'm going to, or same as multiplying by the reciprocal. So I'm going to flip this. Okay, this is my ratio test setup. Okay, lots of things will maybe simplify here. Okay, this and this. Remember, this is really 3 to the k times 3 squared. This is really 3 to the k times 3 to the cube. So the 3 to the k will drop out. You've got 3 cubed over 3 squared. So really all you have is a 3 left on the top. That takes care of that. This and this. The x to the k's will drop out. I still have an x. The k plus 1 and the k plus 2 is still there. Now when you take the limit as k goes to infinity, because the degree on the top and the bottom are the same, that limit is 1. So all you're left with is 3x. Ratio test says it converges if that limit is less than 1. And, right, this is your inequality. Really, you don't have to go all the way to here. This number is your radius of convergence. You are going 1/3 unit to the right and to the left from the center, which is 0. Okay. This one here, I want the exact value of this function. What I would recommend is write out the first couple terms. One thing so I'm going to start at n equals 0. So if I do that, you get cosine of 0. which is 1, 5 to the 0, so I have 1 as my first term. Then go to n equals 1 here, and if you plug in pi, you'll get a negative. You get 5 to the first over 1 factorial. Then if I go to 2 here now for n, this will become a positive 1. You have 5 squared over 2 factorial, etc. And so the pattern continues. Hopefully you can kind of see what the next number will be, etc. Okay, look at your answer choices. Notice that you have either e sine over cosine. These are the functions that we should know. We should know e to the x, cosine of x, sine of x. So when you see this function, what you want to do is recognize, oh, it looks very similar to e to the x, because this is what e to the x is, right? But what are they plugging in for x? They're plugging in 5, but then notice all the signs also alternate. So really they are plugging in negative 5 for x. So this is e to the negative 5. So if you plug in negative 5 for x, notice it gives you the same series that this sigma is.